Your AI agents don't need the cloud. Now, on to the AI
Welcome
learning.
to this guide on running Ollama for Windows. We will cover installation, model selection, API usage, and how DDS Vibe Academy enables you to deploy powerful local AI on your own hardware, with no cloud dependency and no recurring cost. Ollama eliminates cloud dependencies by running large language models directly on your Windows machine. This means no paid API endpoints, no per-token fees, and no data leaving your device, delivering full privacy and predictable, zero-cost operations. Modern consumer GPUs can now power production-grade AI. Ollama is completely free under the MIT license, offers more than 20 ready-to-use models, and after a one-time 1.2 GB download, models run fully offline at 50/70+ tokens per second on an RTX 3060. Model size must align with your GPU. With 12 GB of VRAM, 3B models run at 80 to 100+ tokens per second, 7 to 13B models at 3070+, and 14B models at 1525. Choosing the right size ensures smooth performance for options like Llama, Phi, Mistral, and Qwen. For a 12GB GPU, the performance sweet spot is 7 to 13B parameter models. Use Q4KM quantization to balance speed and quality, and always confirm active models with the Ollama piece command to ensure your hardware is being used efficiently. Installation is straightforward. First, download the 1.2 GB Ollama Setup XE from ollama.com. Next, run it as administrator. Once complete, Ollama starts a background server from the system tray, preparing your environment for local AI workloads. After installation, verify the engine with Ollama version. Then pull your first model, for example, Ollama pull Llama 3.2. Ollama automatically manages quantization and hardware mapping so the downloaded model is optimized for your system. To run and manage models, start a chat with Ollama run Llama 3.2. Use Ollama piece to inspect active models and memory usage. When storage is tight, remove unused models with Ollama RM to reclaim disk space and keep your environment lean. You can add a full web interface using Open WebUI in Docker. The container connects to your local Ollama host and exposes a ChatGPT-style GUI with document upload, web search, and team features, turning your local models into a shared web app. Confirm that the local API server is running by calling http://localhost 111434. A simple curl request validates connectivity. No API keys or external auth are required, and the server auto-starts with Windows, simplifying application integration. Ollama can act as a drop-in replacement for OpenAI endpoints. By changing the base URL to http://localhost 114v1 and using an Ollama API key placeholder, existing OpenAI client code can redirect traffic to your local models with no refactor. For Python projects, install the official Ollama library. It offers a clean typed interface with streaming support for real-time token output. This avoids heavier external SDKs and keeps your application stack focused on local, private inference. Key endpoints include API chat for conversational requests, API embed for vector embeddings, and API tags to list installed models. Using the synthetic director pattern, your app routes logic to these zero-cost localhost APIs at scale. Align model strategy with hardware. Smaller 3B models fully fit VRAM and deliver 80 to 100+ tokens per second for scripting tasks. 7 to 8B models suit general coding and chat, while 13B models, though slower, excel at complex reasoning and generation. The reusable chat request uses a simple JSON body. Specify the model name, a messages array with roles and content, and a stream flag. This single structure underpins most interactions with the Ollama API, simplifying your client implementation. Always match model size to available VRAM. VRAM sets your maximum throughput, so prioritize models that fully fit. Q4KM quantization reduces memory to about 25% of original size, making 7 to 13B models ideal for typical 12GB consumer GPUs. If inference slows to 1 to 3 tokens per second, your model is likely spilling into system RAM. This CPU fallback occurs when layers exceed GPU VRAM. Use the VRAM sizing tables and Ollama piece to downsize models and restore normal performance. Monitor disk usage carefully. A single 13B model can consume 7 to 8 GB. To avoid exhausting your C drive, regularly remove unused models with Ollama RAM, and, when possible, redirect the Ollama model's path to a larger secondary storage device. If you have a strong NVIDIA GPU but see slow speeds, check for missing acceleration. Outdated drivers or legacy compute capability can block GPU use. Ensure compute capability 5.0 or higher, and upgrade to NVIDIA driver version 5.3.1 or later. You are now ready to ship LocalAI without paywalls. Your model fits VRAM. The localhost API is verified, and your codebase targets local endpoints. This stack is free, private, and production-ready, enabling you to deliver real value on your hardware.